I'm going to have an asymptote here. Okay, my graph's going to go hang on, let's do another asymptote. This graph's going to go this way.
Wait, that's the cotangent.
But how do you know where the points are?
Okay, so let's go through the logic again. Okay, I know that anytime it's 1, 1 over 1 will still be on my new graph, right? Because 1 over 1 is 1.
Wait, so 0 is an asymptote?
Right, anytime I go through a 0 in my tangent graph, I need to have an asymptote, because if I do 1 over 0, I have a problem. So that would be where my blue graph was a 0, 0, or at pi 0. Now I have asymptotes on my pink graph.
This is a horrible graph.
Anytime I had an asymptote on tangent, now I have a 0 for cotangent. Okay, and then I just can kind of use what I know about this graph to fill in the blanks.
Is the cotangent supposed to cross at pi 1?
At pi over 2.
So it doesn't hit the... Do you see, like...
This is pi? This one?
Oh, wait, then I'm not looking. The one you circled.
This?
Yes.
That's pi 4th comma 1, and it goes through that point.
It does. Okay.
Wait, so pi is an asymptote?
Right, so now we'll have an asymptote at pi. Everywhere there used to be a 0, now we have an asymptote, and vice versa.
So if they ask us to find the y-intercept of the
Wait, but what
cotangent,
about, there's another
what would
graph
that
on the
be?
other side of 0.
There is a 1.
So what would you write, undefined, or?
Yeah, well, because it's not in the domain, so you can't find a y value.
Okay.
Mrs. D.
Yeah.
So is there a 1 at negative 3 halves pi, 3 pi halves 1 on the other side?
Negative 3 pi is not on my graph. Do you want to be here?
Well, because there's another, I don't understand.
So yeah, I guess there'd be a 0 there, yeah.
But you can't do the cotangent.
You just do 1 divided by tangent. It'll graph it for you. See, there's that point, there's that point. Okay? So does it make sense that the cotangent graph I can kind of derive from what I knew about the tangent? Okay?
To plug it in, it's 1 divided by the tangent.
Yep.
Wait, so the main points are pi over 2 and pi over 4, 1.
Yeah, you can do pi halves comma 0, negative pi halves comma 0. You've got the pi 4ths comma 1.
Oh,
Yep.
yeah. If it was going to be shifted, would we shift the tangent and then make it cotangent, or make it cotangent and then shift it?
I don't think it will
Matter?
but you want to do cotangent graph and then shift it.
Okay.
Yeah. I'd have to think about whether or not it mattered.
So I'm kind of
I
confused.
think it does.
Why 1 over pi stays the same?
Okay. The value of the tangent is 1. And so the cotangent is 1 over 1,
And it's still
or just 1.
So it's
So we're still, both graphs go through that.
okay.
Okay, so this is the cotangent graph. We just derived it. Okay, if you don't feel good about it, work with it in your homework and decide if you can like it. If not, come back. I'll help you. Okay, 2 more. We need sine and cosines, buddies. So please, nicely, on your paper, draw a sine graph.
I forgot.
It starts at 0, 0, it does up and down, and goes up.
It goes up and down.
Well, it does. It
Up
goes
and down.
to
He's
negative
right.
1 to 1.
Wait.
I do remember that.
There's the sine. Right? Keep
Hold on,
going.
don't show me. Wait, so we redraw that?
We're going to try to find a
And then that's
sine.
at pi, right? Yeah. And then 2 pi? Oh, I get this.
But if we have it earlier.
This is the sine graph, isn't it? Okay, so now let's try to do the buddy function of sine from this information.
Wait,
Okay.
wait.
So we're going to try to draw the cosecant.
We're going to pretend that.
Okay.
So 0, 0, 6.
Okay? Brian, I'm not sure you're right on that.
Oh.
What do you guys think about 0, 0? What's 1 over 0?
Oh,
Undefined. Undefined. So every time this graph is 0, we need an asymptote.
Wait, you didn't tell us that yesterday.
That's because we weren't trying this graph yesterday.
Wait, which... Oh,
Real
I'm still
smart.
on sine. Sorry.
Okay.
Sine is 0, we have an S.
Right? Because 1 over 0 is a problem.
Oh my goodness.
It's alright, this graph actually isn't that bad. Okay, what happens when the graph is 1? 1 over 1 is?
I don't get how you want like 1 over 1 and stuff. Like I don't get how you're just getting.
Okay, so Sophie, the sine's value up here is 1, right? And isn't the cosecant 1 over the sine?
You have to remember
So
what
it's
the
still at 1,
cosecant
1?
represents.
Still at, well, no, this is pi halves 1.
I'm just thinking angles. So like I don't get how you like how at the beginning you find like the beginning like numbers. Like how can you plug in?
I'm using the values from the unit circle, and x is turned into the theta. It's the angle value. So if I plug in pi halves for the sine, I get 1. Right? So up here at the top of the unit
for the
circle.
cosecant.
So yeah, cosecant is still at 1.
Oh.
Because it's 1 over whatever the sine value is.
So how is this changing?
So far we haven't dealt with the confusing values. We're doing the easy ones. What about here at negative 1? At 3 pi halves comma negative 1.
Negative 1.
Still negative 1, right? So far all the pink is what we have for our new values. Okay, but now think about this. Aren't all of these fractions? Anything
Yeah.
between 0 and 1?
Uh-huh.
And when I flip over a fraction that's less than 1, what do I get?
They get bigger.
Something bigger than 1. Okay, so see if you can believe me that this graph,
It's gonna start there.
Whoa.
looks like this.
Oh yeah, that makes sense.
Just a bunch of little parabolas.
A bunch of little parabolas, yeah?
And I'm not being sarcastic. That does make sense.
Good. Okay, well notice that just like we talked about, we do have domain issues on the asymptotes. The range is all the things less than negative 1 and all the things bigger than 1.
1 over sine
Wait,
is how you graph it.
Yep. The range is everything except between negative 1 and 1, right? This in between stuff is a no-go for the pink graph, but everything else is a yes.
So how would you write that?
For the range?
Yeah.
Wait, why is it so much taller?
And from
Oh, that's why.
1 to
Zoom in.
That's the range. Right. So now, we talked about that a couple days ago, but now we can see it. Okay? So the only way I can ever draw cosecant graphs is to draw the sine graph and then kind of draw it in. I do it kind of lightly just to give myself an idea.
So how would you stretch that? Like make it
Cosecant is the parabola.
Okay? So,
the range.
if you're going to go like 2, let's say, these U's wouldn't start until 2.
What about if it was like cosecant parentheses 2x?
Okay, then your U's are going to squish, so they'll be half as big.
So it's just like estimating the size of it. Like you can't really.
Well, then instead of having a U be here from 0 to pi, I would have it be from 0 to pi halves if I was trying to squish it.
So with the transformations, they just work like normal parabolas?
Yeah,
Okay.
similar concept, yep. So if you try it and if you have one that confuses you, we'll talk about it tomorrow.
And they do go up too, right? They can go up to like 3 if it's 3.
Yeah, yeah.
Yep.
And
Is
they
it
go all
minus
the way-
3? X minus 3? See when they move up?
No, if it was 3 cosecant of x.
And our calculators will automatically connect them.
Yeah, they kind of do stupid stuff with the asymptotes, yeah. Okay,
Wait, so
let's...
is it just 1 over sine x? Like that?
Yep.
Is that how you?
Yep. So what do you guys think the secant graph's going to look like?
It'll
Kind of
look
like that.
Yep, kind of exactly like that.
Yay.
Okay, but let's draw it in the last minute or 2 that we have. Okay, remember the sine, or cosine graph starts at 1 when we go ahead and draw it.
It tells me pi is not a real number.
Well, that's not true.
That's what I said. So
Oh, but is it an asymptote?
yes, but
Well, then
wouldn't
you
an
don't
asymptote just be blank though, rather than saying
Sometimes,
it's an error?
but maybe this time it won't. So let's try
Trying to line those up. And that's
trace
pretty big graph.
pi halves.
Yeah. Okay.
It should, okay, make sure you're in radian mode. Okay, so here's my cosine graph. That all exciting. Have we stopped and started again?
Once.
Okay, good.
We're almost there again.
Okay. Well, just let it go. Okay, cosecant. This is the secant, so we want to do the secant graph. Right? This is the cosine. We're going to do the secant. So everywhere we have 0, asymptotes.
Oh, that's why you draw it first.
Yep. And then we should have the U's. Yep.
Oh, just the U's in the
The
opposite
U's
direction.
on the opposite,
Gotcha.
they still touch at
For
1 and negative.
secant, the asymptotes are odd multiples of pi halves.
Right. Pi
So
halves,
that's-
yep.
Oh.
Here's pi. Here's 3 pi halves.
Is that always for the cosine?
Yep.
I thought it always
Unless
started
we
at
shift it. Because it always starts at 0, 1.
Oh.
Okay, so if the secant graph looks just like the cosecant, but it's on the tops and bottoms of these humps on the cosine graph.
Okay.
Wyatt? try to, find your more mature side.
The camera's still.
That's
Oh,
all.
no.
Okay? So does everyone think they've got these 4 graphs and you'll be able to do the same type of thing with these, right? Yep. 1 through 14, 15 to 33 up.